This video is about this synthesis practical, which is basically making a nickel complex that looks like this, where the where the thiocyanate is exchanged for different ligands, which are bromide and iodide, effectively, and the bromide, iodide and thiocyanate complexes each have a different colour, which you'll see in the video. So I just mixed some potassium thiocyanate and some nickel nitrate and ethanol, and we've got a pale green precipitate. So I gravity filtered out the green precipitate, and here's my product. Well, I'm not finished yet, but I'm going to react this with something else. So yeah. We got some yellow here. I'm pretty sure this is oxidized nickel. Glove's gone yellow. So I just added some ethylene diamine to my nickel thiocyanate, and it has formed a lovely blue precipitate, almost the same colour as my gloves. Now I'm desiccating my crude product. Right, so I've just dissolved some nickel nitrate, green, and sodium iodide, and some absolute ethanol. We've got some strong alcohol here, my guys. Now I'm gravity filtering off a solution of nickel iodide from potassium nitrate solids, basically. So you use gravity filtration to separate a liquid from a solid, where you want to keep the liquid and you want to discard the solid. Now I'm about to add diethyl ethane diamine to my nickel iodide, and we're hopefully going to get a lovely colourful precipitate. Let's see what happens. And it's going red. Right, I'm gonna go filter this and we'll see what we got. And I've just done vacuum filtration on my precipitate, and that is a nice red colour. So I just got back, it's the next day, so I did some recrystallization, and I only got to partially hot filter my solution, which left me with some lovely blue crystals here and some not so lovely blue crystals here, since I didn't get to filter it. Yeah, so now I'm going to go characterize these. Also, just look how messy my fucking fume hood is. It's not great. Doing some suction filtration, and my crystals are bouncing everywhere. Look at that. It's because of the vacuum pump. It's making the whole table vibrate with my suction filtration on the clamp. Just dissolved some nickel bromide into some ethanol. It's still dissolving actually, but yeah, I made a yellow solution. Pretty cool. Got my my solution of nickel bromide and 1 milliliter of just some amine. I can't be bothered to name it. And let's mix these together and make a precipitate. Suction filtration of my nickel bromide and amine complex, and it was originally orange, but the more I try it, the more blue it goes. So I'm pretty sure the anhydrous complex is blue and the hydrated complex is orange. So I've got two different colours in it. It's pretty nice actually. It's orange and blue, my favourite colour combo, man. Oh, it's so good. Now I'm doing some IR spectroscopy on my product, so I've got some of my crude Thiocyanate complex here on a spectrometer, so let's just crush it down into the crystals. I'm pretty sure it's, I'm actually not sure what it is. I think diamonds are good, I'm not sure if this is using diamonds though. Anyway, we're going to shine some infrared light on this and get an infrared spectrum. So if we just close this, and then click scan, and then scan again. On a, I don't even know what this is, it looks like Windows 2000 or something. This is very outdated, but it works, so yay. And here's my Spectrum. It looks just like the last one because it's the same thing, just crude. And there we go. This is overlaid with the previous Spectrum. I'll delete it. Right, I'm doing a melting point determination. I've got my orange and my blue in there. And I'm just doing a really quick ramp up to temperature just so I can see when they melt very quickly, basically. And then I'll have a good ballpark value. Let's see if we can watch them melt. Now I'm just waiting for my Thiocyanate Complex to melt, basically. There it is. It's 200 degrees. Still hasn't melted. Here comes the melting point, hopefully. This might be a very long video, not gonna lie. At least I'll catch it on camera so I can see when it melts. And that looks like it's just about started to liquefy. It's only partially liquefied though. Yeah, that's definitely turning into a liquid. So I would make the melting point about 209.7. It's when it started to melt. Obviously it's gone up a bit now. So the melting point, let's say it was 209.7. And yeah, there it goes. I measured the magnetic susceptibilities and the length of the sample in the sample tube, but I didn't measure the mass. So I gotta redo everything. Right, I'm done. I got all of my metal complexes. On the left here are 3 different purities of a Thiocyanate complex. Here I've got my nickel iodide complex. Here I've got my nickel complex. And I've also got my magnetic susceptibilities. I've got a melting point, the cyanate one, and then the other one down on the iPad. And I've got a load of IR spectra, which I'm going to have to scan. So there we go. I just got to clear up this fucking mess now. So I think it would be good to go through some of the theory behind the practical method, effectively. So the gist of what we were doing in the practical was reacting just a solution of some ionic nickel compound that you can see here, nickel hexaaqua with some anion, which could be thiocyanate, bromide, or iodide, with this amine, known as diethyl ethane diamine, because it's ethane with 2 amine groups and 2 ethane groups attached to it, and you end up getting a ligand exchange with the equatorial ligands, so the ones around the equator, effectively. And so yeah, you end up getting this structure here, which is, well, I say it's a solid, but it's more insoluble in the solvent we're using for this reaction, which was ethanol. This is insoluble in ethanol, this is soluble in ethanol, and I think that can be reasoned by the fact that these have charges on them. Charged species are more soluble in polar solvents. Ethanol is a polar solvent, it exhibits hydrogen bonding, whereas this does not have a charge on it, so it's going to be less soluble in ethanol. I think there will be some extent of an equilibrium between this complex here and this complex down here, where you can get your anions potentially forming ligands with the nickel. Oh, I'm missing an I. Let me just add that in, one sec. So yeah. Don't know why the I hasn't appeared, but I can tell you I added it in. Anyway. Still hasn't appeared, okay. So
So some examples of basically this reaction. Oh, there it is. Um, so let's start with the thiocyanate complex. While making the thiocyanate complex. So this was a reaction. So first we need to make our nickel thiocyanate to react it with the amine, as you can see here. To do that, just react nickel nitrate with some potassium thiocyanate and ethanol. This produces potassium nitrate, which is insoluble in ethanol, so we get a solid forming in a precipitation reaction, which we can then separate from our solution of nickel thiocyanate in ethanol using gravity filtration. And you use gravity filtration because you want to have the liquid as pure as possible, and that is achieved by the fact that there's a very low chance of any of the solid getting past the filter paper if you carry this filtration out properly. So once you react the nickel thiocyanate with the amine, you get this insoluble complex which precipitates out, and in this case it was a nice blue. You can see it here. So to purify this complex, because obviously there's still ethanol in there with probably just some leftover impurities from these reactions, you first vacuum filter it. You can kind of see the vacuum filtration here. You saw it in the video. It's just have a pump with a Buckner funnel. So after it's been vacuum filtered, you put it in a desiccator to dry it out, and then you dissolve effectively this but dry in really hot methanol, because that increases the solubility in the methanol. I added way too much methanol because there were some insoluble impurities. As you can see, this one on the left is a bit cloudy, so I just thought it wasn't dissolving fully, added way too much ethanol. And then I realized after a while, oh, actually there's insoluble impurities. I should do a hot filtration, which is just filtering while the methanol is still hot. I ran out of time, so I didn't complete my hot filtration, but I did partially complete it. So as you can see, this one is not cloudy. This is the result of the hot filtration. This was not filtered. And then once the methanol was allowed to cool, the solubility of my thiocyanate complex here in the methanol at a lower temperature decreases, and it comes out of solution and forms crystals, which formed overnight. I think these crystals are much larger because there's fewer sites for crystals to form in here, because there aren't really any insoluble impurities, maybe a few. And so yeah, fewer sites means the crystals will form much bigger because there's fewer places for them to form, so all of the material will clump into one place effectively. Whereas here the crystals are much more frequent and much smaller because there's more places for the crystals to start forming. So secondly was forming the iodide complex. So similarly to above, we had to form the nickel iodide, which you do by reacting sodium iodide with nickel nitrate, forming insoluble sodium nitrate, very similar to potassium nitrate, insoluble. Filter it, get your nickel iodide, also green due to nickel hexa aqua being green. That's why this is green and this is green. And then adding your amine, you get this complex, very similar to the complex above, just instead of thiocyanate, you have iodide, and this is a lovely orange colour. I did not purify it any further, it wasn't part of the practical script effectively. And then finally, the bromide complex. It didn't have to make the nickel bromide, we just had it as a reagent, dissolved that in some ethanol, added the amine. As you can see here, I'm adding the amine to the solution in ethanol. And this is also green, and you end up getting same complex as above, just with bromide instead of iodide or thiocyanate. And this is blue and orange. The blue is the hydrated complex. I imagine it's being hydrated by water in the air. I can't imagine where else the water would really be coming from in this case. This actually, the solid form of this does have some water in it. So that would be a contributor. But this orange stuff is the anhydrous stuff, and when I first did the reaction it was all orange, so yeah, it's being hydrated. The orange is anhydrous and the blue is hydrous, basically. And so yeah, that's all the reactions in the practical. Oh, and finally, here's all of my sample vials. So I've got the bromide complex, the iodide complex, and then a progression of different purities of the thiocyanate. So this is the one that was filtered while it was hot. This is the one that was recrystallized but not filtered while it was hot. And this is the one that was just crude, just collected by vacuum filtration without any recrystallization in the same way as this one and this one. Which is why these have very fine powders with small crystals, because the crystals were formed very quickly, whereas these crystals are much larger because they were literally left overnight. Yeah. So there we go. That's the nickel complex practical.